That's pretty much just all the numbers, that's not decimal.
Yeah, any number that's not a decimal is an integer. See how the list just gets bigger and bigger? I kind of wrote them in order. Rationals.
Anything that doesn't have imaginary numbers.
Nope.
Yes.
It's
Are
like
you
rational.
The whole number is gonna have decimals, right? It's a
Nope.
number that eventually ends.
Not necessarily.
Because I know
It's a
that-
number that can be represented by a fraction.
Yeah, because pi is an irrational number. Pi is irrational.
So things like 1/3, that's rational. All of these are rational, because you can just put them over 1. Other rationals, 1/3, half, any fraction, or even decimals. Like 0.25, that's a rational, because it can be represented as 1/4. 0.327. That's rational because it can be represented by, if you know, you get 5 gold stars. 327 over 1,000. You can do that with any decimal. Any decimal that ends, you can just put it over a 1 with 1 extra 0 to where it has 1 extra 0. Then, yeah, like so if it has 3 digits, put a 1 and 3 zeros, and that'll be the decimal version of it.
That's 327,000.
Yeah. Yeah, 327 thousandths, and that's how you read that. Tens, hundreds, thousands. Oh, mind-blowing stuff here, huh? This is how numbers work. Those are all rationals. Even decimals that don't end, like 0.33333333333. As long as it can be represented by a fraction, it's rational. So that's 1/3. The way the decimal things works with rationals, if it repeats, it's rational. Like 0.3333 or 0.666. Those are common ones.
No.
Those are rational. Or if it ends, it's rational, because like I said, you just put a 1 with that many zeros and then you could have it. Irrationals are decimals that go on forever that don't repeat, like pi is one example. Goes on forever, never repeats. Another example, numbers like the square root of 2, the square root of 3, the square root of 5, those numbers.
Wait, I have a question. What do you mean it never repeats?
It never, like, 0.3333 repeats itself over and over and over. If I do something like 1 divided by 7, you look at that, and you can't see it on this calculator because it doesn't go enough digits. But this goes 0.142857. The calculator rounds it, and it'll repeat. It'll go 142857, 142857, 142857, 14. It repeats over and over and over and over.
How long have
Oh.
they found?
It's rational because it can be represented by 1/7. That's just how it works out.
How long have they found pi to be?
Millions of digits. Pi never repeats. There's never a pattern. Like it's just always just random. Of course,
2 4s,
individual
2.
numbers repeat. Yeah, like you can have 9 right there,
4, 4.
or 4 but there's never like strings of numbers that repeat themselves over and over and over and over again.
There's not a pattern.
There's no pattern or anything.
So couldn't you say any square root of a prime number is irrational?
Yeah.
Well, I thought that like the scientists did like a study where it took them like 3 days to figure out a pattern.
For pi?
Yeah.
No, there isn't one. It's irrational. There's no patterns on irrationals.
Would it run out of numbers?
Like square root of 2, well, the calculator's a bad. You need more digits than this little calculator. But like even that, there's no. It's 1.4, 1, 2, 1, 3, 5, 6, 2. It'll never repeat or anything. It's just always just going to be different numbers. If you do like 1/8, you'll see a pattern. Oh, it's 0.125. It ends. It'll either end or you'll see a pattern. 1/9, you'll see a pattern. 0.1111111, it repeats. Pick any fraction. 27/49. Calculator's not long enough. I guarantee you it repeats though. Should do it on a computer. I bet you there's a computer if we just Google like calculator with many digits. But we don't need to. Just trust me. So those are all real numbers. Then you just learned about imaginary numbers. Imaginary numbers have i's, in them. They're the square roots of negatives. Just learned about that. So then the last kind, complex numbers. What's complex mean? Complicated? Yeah. It's because complex numbers have two parts. They have a real part and an imaginary part. Complex numbers are always written a plus or minus bi, where you have a real part and you have your imaginary part. So the answers to all of those homeworks from yesterday were all complex numbers. You notice that? That's why I had you write them in that form, to simplify it all the way down the way I did. You always had a real part and an imaginary part on every single one of them. We can do operations on complex numbers too. We can add them together, we can subtract them. It's really easy.
And I'm assuming that we're going to.
Oh yeah, we're going to do it right now, as a matter of fact. For example, addition. We'll just use our answers from yesterday. What? Let's see. The first, number 2 is 2. Well, let's not. Never mind, I'm not going to use those. Those are fractions and stuff. We can add complex numbers. Like say one of them is 2 plus 3i. I can add that to pick some numbers. 5 minus 7i. Those are two complex numbers and we can add them together. It's very easy. I bet you can guess the answer. No.
Is it?
Your answer will be a complex number.
Is it 7 plus 4i?
Yes, it is. No, it isn't. 7 minus 4i would be the answer.
Seriously?
You're just it's like combining like terms. 2 plus 5 is 7. 3 plus negative 7i is negative 4i. It's just like combining like terms with x's. That's all it is.
Oh, okay.
It's really that easy. Same thing with subtraction. If you like negative 4
But then you wouldn't do 5 times 3i.
times? No, it's addition. Same with subtraction. We can do
How would that work out?
Negative 2 plus 7i.
So negative.
Negative 2. 2 negatives make positive.
That's would be plus net minus 2.
You probably want to distribute the negative, make it easier on yourself.
Yes, we.
So it'd be negative 10, it'd be plus 2 minus 6i. So you have negative 4 plus i. So negative 4 plus 2 is negative 2. I minus 6i, negative 5i. There you go.
Oh, yeah. Oh, because it was a negative? That's why you said that.
Yeah, for the subtraction. Distribute the negative, or just think of it as subtract both of those.
Okay.
Remember the web page we were looking at the other day with the electrical stuff?
Oh,
They were talking about doing this because you like when they're adding currents together, they're using the imaginary numbers and adding them. Pretty simple. Multiplication is like a tiny bit harder. Just a tiny bit. So let's multiply. We'll just pick these two and multiply them. Instead of adding them, now I'm going to multiply them. 2 plus 3i multiplied by 5 minus 7i.
10 plus
Yep, just like with x, distributive
21
property.
I squared.
10, 2 times negative 7 is negative 14i.
Oh,
Right, remember distributive property? 3i times 5 plus 15i. What's 3i times negative 7i?
Negative 21.
Negative 21
I
I squared.
Oh, yeah.
Okay.
I times
We can combine our like terms. We got 10. Negative 14 plus 15 would be plus 1i, which is plus I. Here's the, I remember I said it's a tiny bit harder. Here's the tiny bit part.
Wait, how is it just 10?
What's I squared equal to?
So it could be.
So it's
I squared is negative 1, remember that? I is The square root of negative 1, I squared. Square root of negative 1 times square root is negative 1. We talked about that a couple days
So
ago.
it's negative 22.
So this is negative 21 times negative 1.
Oh.
So it's plus 21.
What the?
So your final answer then is 31 plus I. There's the tiny bit. Tail? 2 times 5. Distributive property. FOIL it out. First, outer, inner, last.
So 31 plus.
So what if it would have been? What if it would have been just I?
Then you would just combine them with these.
Oh.
It's
too
because,
precious.
you didn't put one in that, so it threw me off.
Oh yeah, one eye.
I figured it out.
One eye.
Madness.
Okay. Want to try some? That's all we're gonna do today. You're gonna add and subtract and multiply or complex numbers.
Worksheet?
No, got them right here. I wrote them on the bus though last night, so they're kind of.
Can I go make copies?
I can rewrite.
Yeah.
What?
Copies.
Yeah, everyone can make their own copy with a pencil. Here we go. Number 1. It won't take long.
Can I just write the answer? Can I just write the answer?
Sure. Multiplication ones you might not be able to do. 7th period, I hope you're keeping up, doing your homework like you're supposed to do. You're still going to have to take the quizzes the same days as these guys. Right.